So it says in the figure shown, one circle is circumscribed around a square with a side length of 2 units, and another circle is inscribed in the same square. Okay, so the one that's circumscribed around the square has a side length of 2. So this right here is 2, which would mean that this line right here, since it's a square, is also 2, the one that goes through the middle of the circle, the center of the circle, which would mean that the radius is 1. So the area of the small circle, if we want to say the area of the small circle, that's equal to pi r squared. And if the radius is 1, then the area of the small circle is equal to just pi, because I could say 1 squared, but then I'd have to say area of the small circle is equal to just pi, since r is 1. Okay, for the large circle, we would think a little differently. Let me erase that line. We would say, for our large circle, we're thinking about this line that goes across the square. So what we have there, if you can visualize that, is this triangle. We have this triangle here. Maybe I'll try that again. We have this triangle inside. I'll try to make it more clear out here, with a side of 2 and a side of 2. It's not drawn to scale. But Pythagoras says that if I square these sides and add them together, 2 squared plus 2 squared, that should equal c squared. So I get 4 plus 4 is equal to c squared. Where'd my square go? So I have 8 is equal to c squared. So then that must mean, if I switch c over here, I'm going to say c is equal to the square root of 8. The square root of 8 is 2 times 2 times 2. I can take 2 of those to the outside, so c is the hypotenuse, or the diameter. It's equal to 2 times the square root of 2. Okay, so if the diameter here of the circle is 2 square root of 2, then half of that, if I divide this by half, let me change color to show it's not part of the same thing. 2 square root of 2 divided by 2, the 2's cancel. So my radius for my large circle, let me say the area of the large circle is equal to pi r squared again. And so I'd say the area of the large circle is equal to pi square root of 2 squared, right? Because the radius is square root of 2 squared. And if I square the square root of 2, then the area of the large circle is equal to 2 pi then, because it's just 2. The square root of 2 squared is 2. Okay, so then it says I'm supposed to compare the area of a small circle and 1 over the square root of 2 area of a large circle. So, okay, we're going to say 2 pi, and we're going to divide that by square root of 2, because they said I was supposed to have 1 over the square root of 2. And so if I do that, I can square the top and the bottom. Let's see. Don't want to do that. I'm going to take the square root of 2 times the top and the bottom, and I'll say 2 square root of 2 times pi over 2. The 2's will cancel, and so I'm comparing the area of the small circle, which is pi, and that is going to be less than the square root of 2 times pi. So as you can see, this is the smaller one over here, the area of the small, and this is the area of the large divided by the square root of 2. So that's bigger. So if you wanted to assign that to be A for the small circle and B for the large circle, we'd say that B is larger than A. Kind of different, but it helps you think about circles. It helps you remind you of the vocabulary that if you're around the square with a circle, you're circumscribing it, and if you're inside, the circle is inside the square, it's been inscribed. Just don't want you to forget too much geometry.